Good, Corin. I'm glad. Good, Kellen. Mine too. Um, so let's think. This week, just as a reminder, I did send an email out to remind you of everything for the week, and I sent, maybe I didn't send you guys one yet. I will. And I'll post a reminder up in e-learning as well. But for class this week, just some reminders as to where we are and what's due and that kind of thing. So your next test is due on Wednesday. Keep my dates straight. I did Wednesday in one class and Thursday in another one, and I should have made them both Thursday because I'm confusing myself half the time. So test number 2 is due on September 30th, which is Thursday, which is Wednesday. See, I did it again, which is Wednesday. And that's the test over chapter 3. And then we're going to be working on systems of linear equations and applications. So that's sort of what we'll be working on the rest of this week beyond what's on the test. So I'm going to open it up first to questions from anybody who, especially if you have questions that you want to get answered before you go to take the test, shout those out or type them in the chat so we can work on them. Corin, how have you been doing?
I've been doing good. Sorry I can't make it to the Wednesday and Fridays because I have to work, but I try to make sure I come Mondays.
Okay, and remember that everything's getting recorded so you can go listen. I've been trying, I tried to be extra diligent this morning in my 10 o'clock class to I was going to let people work on questions to pause so there's not a big long blank space in there.
Yeah,
so they should get a little shorter if I'm able to do that a little bit more.
Yeah, the recordings are really helpful, so thank you for that.
Okay, good.
The only thing that I probably have trouble with is the 2 ending ones, the one in Alta Newton that are ending chapter 3. I think it's the line regression and then the line vertical test, the vertical line test.
Linear regression and then vertical line test?
Yeah.
Okay, so the linear regression, I did do that in Wednesday's class last week.
Okay, I'll have to go back.
So check that one because I show you how to do that on both the calculator and in Desmos. So if you're using Desmos, you got instruction there as well. And also if you're using the calculator, I held up the calculator because nothing else seemed to work very well. But yeah.
All right, I'll give that a look.
Give that a look. And then if that doesn't work, just, either pop into office hours or email me for a time when we could meet and I can show you how to do that in technology because you definitely have to use technology for those. And you definitely want to have that down because that's going to be on the project. Yeah,
and I'm definitely familiar with the Desmos because I use that basically all through.
Okay, so and another handy thing about Desmos with this is that if you have the data from say Alta and you need to get it into Desmos, you can actually just copy and paste it in there and it'll make a table for you. Okay. So that makes it really nice because you don't have to type it in, especially if there's a big, long bunch of data that you would have to enter.
Yeah, thank you.
Okay, and Samantha says she needs help finding the parent function when looking at the graph. Okay, that's a good question, Samantha. I like that one because that's a nice broad idea of a question. So what you want to look at on there is what sort of the basic graph looks like. Oh, and there's my previous one done. So yeah, that'd be great, Samantha, if you can share your screen. Go ahead and do that so I can see specifically what problem or problems you're looking at. Samantha, are you sharing?
Yeah, she is. I think you have to click on her name to have her screen like pop up in the middle.
That's what, oh no, I know. Got it. I just need to pin it. Okay. So what we want to do is and so what did the instructions say on this? Can you scroll over there? Identify the parent function of the function who's, okay. So we really do just have to learn some basic function shapes. And this is just, you'll get used to these as you go. But a couple that we'll start with are, just think powers of X. So if we go off to say either Desmos or to a graphing calculator, I'm going to steal the screen share, and I'm going to share my screen. So it's probably going to tell me that. Yeah, that's fine. No, I don't really want to get back in there. Okay, so let's go to Desmos. You really probably at this point in time, I think there are about 5 functions that you're going to want to worry about for parent functions. So the first function is just going to be our basic straight line. So if you see a straight line as the function, then the parent function would be y equals x. The next one is a parabola. So if you see that sort of U shape, that's going to be y equals x squared. So I'm up to 2. The next one, we're going to go up one more power of x. And we could keep going if we needed to, but I think this kind of gets us the idea. Y equals x cubed. Notice this is kind of like our y equals x in that it goes uphill from left to right, but we get this weird sort of squiggle in the middle. And that looks an awful lot like the graph that they gave you. So there's your parent function for the problem you showed me. But let's look at a couple more. The next one that you probably will want to have sort of in your bag of tricks is the square root function, which is like that parabola, but it's turned on its side and there's only half of it. They can't put the whole parabola in or it wouldn't be a function because we would fail that vertical line test. And then finally, I said 5, so I'm going to stick to my word. The last one is going to be the absolute value function. So remember, the absolute value function returns the distance from 0, which means it's not negative. So it's a V shape. Kind of looks like the parabola in a way in terms of where it's positive, but it's a straight line V as opposed to more like a U. So it's not a smooth turn. It's a big sharp turn at the origin. So if you see that V shape, think absolute value. So now if we go back and look at my screen, your screen again, I'll unshare mine. And let's see, I guess you're still pinned. Go ahead and share yours again, Samantha.
It's not on that problem anymore.
Oh, you left that one. You did it and went on. Okay, that's fine.
Yeah.
All right, so you see how that's the x cubed. And I think those 5 functions should serve you really well in there. It should be one of those 5.
The mx plus b looks a lot like the y equals x.
Okay, so they use the mx plus b as the parent function instead of just plain y equals x. Yes, it would. So yeah, that would be the y equals mx plus b. Okay. And if you're then not sure, you can always graph the one they give you. And if they give it to you with parameters in there, like the M and the B, those are called parameters, you could just pick some numbers and then see if they look similar, if it looks similar to the graph they gave you. So for example, choose M and B both to be 1. So graph y equals x plus 1. And if it has the same shape as the graph they gave you, then it's the parent function. Okay. Are there others? Do you want to try another one of those, Samantha, or are you good with maybe the rest of them now?
I think I'm good with the rest of them now.
Okay. Let's see. Finding the parent function. So are there other kinds of questions in there that you guys have? Trying to remember. Let's go back and take a peek. Intro to functions, function notation, vertical line test. I think Corin, you said you were having a little bit of trouble with the vertical line test.
Yeah.
All right, let's
Understanding it, yeah.
Okay, let's go ahead and take a look at a couple of those. How's that sound?
Sounds good.
We'll just pick some out in here. So vertical line test and graphs of functions, that's the one. And I don't want to go to students. I just want to preview as a student. Okay, so I'm going to open these up and notice we have 3 objectives in here. Use the vertical line test to decide if we've got a function. Read information from a graph, and then identify graphs of basic functions. So this is folded in with, I think, with the questions like what Samantha was asking about here. Okay, so they also gave you some problems in here with domain and range. Were you struggling with those as well, or was anybody else? Do you want to see those?
We can go over it. I think for me personally, I didn't understand at first, but it was just something that I had to continue to like practice to get it right.
Okay, so they do give you a little bit of a hint on these, in that notice they used square brackets on the number lines where they are showing you what the domain and range are. Remember, the domain is all of the x values that show up. So that's going to be horizontal. And the range is all of the y values that show up. And they want us to write these in interval notation. So domain starts at -7. So square bracket, -7, comma, -2, and then square bracket closing. And then
seeing your screen.
What'd you say? Oh, I'm not sharing. Silly me. Crazy. This one, I think. Let's see if I got the right one. Yes, I did. Okay. Very good. Okay. So I'm going to just open that up a little bit. That should be better. So -7 to -2 is our domain. We know that we want to include those endpoints because they included them on the graph. And then the same for range. We want to include the endpoints, and we're going to go from -4 up to 7. So the range is the y values, square bracket, -4, comma, 7, close square bracket. And that should be good. We can submit, and hopefully we got that right. I'm going to close that up. What did I do wrong?
Looks like you put a period instead of a comma for the domain.
Well, silly me. I did, maybe. You think that's a period? Or is there an extra space? No. We'll double check this one as well. Comma 7. What if there's something else I have in there extra? We'll find out. Nope, you were right. Thank you. And we'll only do more. Okay, so here's one of these parent function problems again. This is a horizontal line. So what you could do is you could graph each of these, or any you need to select the parent function. But as I glance through these, I'm going to start at the bottom. I know it's not the absolute value because that's my v, so that's out. This doesn't look like a v. It's not my square root function. That's the one that looks like part of a parabola laying on its side. This is just a flat line. It's not the x cubed because that's the one that's squiggled up through the origin. It's not the x squared. That's my parabola, so that's out. F of x equals mx plus b is a slanted line with slope m. You know, maybe it slants upward, maybe it slants downward. Or f of x equals b, which remember b is just a constant. So like y equals 2, or in this case, y equals 0. That's a horizontal line. So f of x equals b is a horizontal line. That's the one we're going to choose. We should be good. Hopefully we'll get to those vertical line test problems in a minute. There we go. So Corin, take a peek at this. They just want us to decide whether or not we've got a function. And the idea is going to be that if an x value gives us 2 y values, then we don't have a function. If an x value gives us 2 y values, then we don't have a function. Just double checking to make sure I was recording. It looks like I am, so I think we're good. So a vertical line that passes through the graph more than once tells us one x value has at least 2 y values. So for example, at -4, at x equals -4, there's a positive y value and there's also a negative y value. Since that happens, this graph fails the vertical line test and we would say, nope, this is not a function. If we only had the top halves of each of those little pieces, then we would have had a function. But since that bottom half was there and we curved back around on ourselves, this one's not a function. And then they even showed us. It doesn't matter that this line in the middle doesn't hit anything. That's really neither here nor there. It's just that there are some lines where one input gives us 2 outputs.
Yeah, that makes a lot more sense. I think it was just like the problems that, like you said about the parent functions, like knowing what function.
Oh, okay. So it was in this section, but it wasn't really the vertical line test questions.
Well, it was the vertical line test question. I guess it was just like all mixed together. That was kind of knowing what to do and not what to do or whatever. Okay,
so quick one on this one. They asked for the domain and range, which we could type in, but we just did that. Tell me, is this one a function or not a function? They didn't ask for that here. So the graph starts here and comes up and then back down. Does this one pass the vertical line test?
Yes.
Yes, so that would be a function. They didn't want that. They wanted domain and range, which are not. Oh, it won't let me use the cheat. Really? I don't know why it's not filling in. That's kind of mean. What would we get? -3 to 7 and -2 to 0. We're just gonna submit. Oh, it's there. It's just not showing it. I forgot it doesn't show in there. It just lets me move on. And we'll continue. All right, function or not a function?
Function.
Function. What if it was the entire circle?
Would be not a function.
Right. So I think we're good here. We'll submit that one. Then we'll continue. And then we'll just get back out of here. Okay, any others that you guys can think of? We can peek back here. Let's see. So someone mentioned linear regression. Should we do a quick one? Just to see how that works?
Yes, please.
Okay. And whoever said yes, do you want to do this in Desmos or graphing?
I use my calculator, so
Okay,
I would
so if
prefer
we're going
that.
to use the calculator, I got to go steal a calculator from my daughter.
Oh,
That's okay. She's not doing math right now. I'll just be right back. So give me a sec. Okay, so on your calculator, and who was that asked this one? I'm going to stop this share so we won't need it.
me, Megan.
Me, Megan. Okay, so you,
Yeah.
Megan, on your calculator, you got a TI-84 or an Inspire of some sort?
I have a TI-84.
Okay, cool. That means we're looking at the same calculator, so that makes it a little simpler. So the first thing you're going to do is you're going to go find the stat button, which is second row, third column.
Mm-hmm.
You got that?
Yes.
Okay, so press that.
Mm-hmm.
And then you should see across the top, it should say edit, calc, and tests.
Yeah.
And edit should be highlighted.
Yeah.
And then you've got like 5 choices.
Mm-hmm.
So we're just going to use the edit choice. So hit enter.
Mm-hmm.
And what should happen is that you get
A bunch of columns.
you get a bunch of columns. And so, like, there's mine. I had numbers in there from before.
Yeah.
Yep. Okay, cool. So what you can do now is if you want to get rid of those numbers, is that what you want to do right now?
I don't have
want to
numbers
use
on
those
mine,
numbers?
but
So, I mean, I want you to know how to do that.
yeah.
So if you want to get rid of those numbers in a list, you can arrow up so that the list is highlighted. So I use my arrow up so L2 is highlighted.
Mm-hmm.
And then just press clear.
Okay.
I'm not going to do that right now on mine because I'm going to use these numbers. So you're going to always put your X's in list 1 and your Y's in list 2. Now you can use other lists if you want, but it's probably simplest if you just stick to the first 2 because then you'll know where they are.
Okay.
Let me unpin that. There we go. Okay, that's better. So now The next thing you want to do, once you've got something in each of those lists, there are a few things that that you'll want. And I did post a document that shows you how to do this on the 83 and 84 up in e-learning. I don't know if you accessed that yet or not, but that's there in case you need it. The next thing you're going to want to do is let's plot these. And the thing we need to do is make sure that the plot is turned on. So we're going to go back to that, into our stat plot, which actually let's just clear that. So look at your y equals, and right above it, it should say stat plot. You see that? So we're going to hit second and then stat plot. And you should get something that looks kind of like that, although on yours, it might be a little different. What's the first line say? Is it like plot 1 on, plot 2 off?
Yeah, it just has a glare.
Yeah, okay. So on the plot 1, make sure it's turned on. And then you're going to choose your different things. So on my calculator, I just hit enter, and then I come to a new screen where I get to make my choices. Yours should be similar. So we're going to turn it on, and we're going to choose the very first plot, and then list 1, list 2, and the big dots. So it should look something like that. Is it pretty close? Okay, cool. So once you've got that, we're ready to plot the points. And we're going to do that really quickly by hitting zoom and then number 9. Number 9 is for stat plot. So zoom and then 9. And my graph looks like that.
I have a TI-83, so it's kind of the same. But when I did zoom 9, it says there's an invalid, I think it stands for dimension. And
Okay, so if that happened, it's not because it's an 83. It's because somewhere in your lists, maybe you have 4 items in one list and 5 items in the other list, or something similar to that. But you have to have put your information into your lists. It could also be that you have nothing in your list. That will also give you an invalid dimension error.
Okay.
So make sure you put your X's in list 1 and your Y's in list 2 before you do that, Corin.
Okay.
I was wondering, because I accidentally deleted like the, you know how there's like the graph or whatever, like the chart? I accidentally deleted like the L little 2. I don't know how to get that.
Oh, yeah. Okay. So at least 3 students a semester do this. So don't worry, you won't be the only one.
Mm-hmm.
And this is a good time for it to happen because there's people here and you guys, I could show you how to get it back.
Yeah.
So when you go on this screen,
Mm-hmm.
do you see how number 5 is setup editor?
Yeah.
If you go down there and choose that and hit enter, it'll bring it up on the main screen.
Mm-hmm.
And then you can hit enter again and they'll all be back.
Oh, yay. Okay. Thank you.
Yeah. You're not first and you won't be the last, so don't worry about it. Somebody deletes a list. Yeah. Every time. Okay, so once you have everything in there, can you graph that now? See if you can graph some points. Just make sure you can do that with your Zoom 9. So these were, I mean, you might have different points in there than me, but that's what I had in there from before. Now, that doesn't give us our equation. To get our regression equation, we're going to go back to stat again. And this is where things sort of vary depending on what calculator you have. Although the 83s and 84s are pretty close. It's those Inspires that do things a little differently. And then the newer 84s do things differently than mine does. But you're going to go over to calc for calculate. And then down to linear regression, which is choice number 4 on my calculator. And I think it should be on yours too. So you're going to go down to choice 4 and hit enter. And then you have to hit enter one more time, and on your, depending on your calculator, like mine just shows up on my home screen. And it tells me what my slope and my y-intercept are. Yours, yeah, glare. Yep, same thing, looks good. Now, if you want, you can, you want to get those into your y equals, you can just type them in if you want. Sometimes it's easier to have the calculator remember as many of the digits as possible. So I like to go to my y equals. I'm gonna clear this out. So my y equals looks like that right now. There's nothing in there. And then I'm gonna put that regression equation in there. And this is where the handout with the steps is nice because you can see it in print. So really slowly, we're gonna go and we're gonna hit the VARS key, V-A-R-S. And then we're gonna go down to number 5, statistics. I'm gonna type this as I go and I'll hit enter, VARS 5 for statistics. And then over to EQ for equations, and then number 1 for regression equation. So this is the screen we're shooting for. Now, if you have a newer calculator, it's a little simpler than that. But that's what I had to do on my calculator, which is a little older. And when I did that, it just dumped it right into my Y1. So it's sitting there for me. And again, we might have different equations because I'm not sure if we have the same data or not. So when you went in there, is that what you had to do, or is yours the one with, I think yours is
this glare.
you got the newer one where you just enter everything on one screen, right?
I think so. I had to go through the steps that you had to do to put it in.
Okay.
So,
All right. So once you have that in there, then if you hit graph, it'll graph the line along with the points. So we can see the line looks like a pretty good approximation. That is the best fit line. That is the one where essentially the sum of the squares of the distances from those points to the line are minimized. That's a mouthful to remember. You don't have to memorize that. It's just the best fit in the sense of kind of getting the points as close to the line as possible. Not too high, not too low, not too steep, not too flat. And then you can make predictions. So then maybe, you know, if you wanted to predict what happens when X is 10, you could plug in 10 for X and solve for Y. Or you might want to know what X value goes with Y equals 25. You could plug in Y equals 25 and solve for X. And you would have that equation to work with. And then Alta will tell you how many decimal places to round to, because you'll almost always need to round.
thank you.
You're welcome. Okay, anybody else on that? Are you guys good? Is that helpful? All right, and remember, you can also watch back, I think it's last Wednesday's class where we did that as well, and we did both the calculator and Desmos. So Desmos is kind of nice because if we, actually, let's do this. Let's go to intermediate algebra. Let's go to linear regressions. And I'll go back and share this screen again. So I know I'm not sharing just yet. Share screen. One. Oops, I grabbed the wrong screen. Oh no, I didn't. Okay, let's just get rid of that. Okay, so linear regression, option, preview as student. Okay, so notice how they gave us a table of values and it's got like 8 points in it. So X value, Y value, 0 to 7. So we've got 8 points and they want us to round to 2 decimal places. So watch this. We're gonna copy, I think we can do this. Oh yeah, copy to clipboard. They even gave us this. You can also download it if you want, but I think copy to clipboard will work. Then we're gonna just jump over to Desmos. And go to the graphing calculator. And we're gonna go in there and we're gonna paste all that info in. And there it is. So I can just sort of do a quick copy and paste into Desmos and the points get plotted automatically. We get the nice notation, X1, Y1 for our table. And then we do have to remember what the format is for an equation of a line. So we just go Y1, and remember it was this little tilde, approximately equal to MX1 plus B. And there's the line. And then down here, there's our M and our B. So we would use Y equals 0.32X plus 4.11 on that one. And they even gave us a nice little format to put it in here, 4.11. And we were right. And they described how to do it with the TI 83 or 84. So if you get into these, notice that they do give you the list of steps in the answer explanation from the TI. And then we just got another one, so not too bad. So in the project that you're going to do, you might have quite a bit of data, but I will supply the document to you in like a Word format, so you'll be able to copy and paste that if you want to use Desmos to make that data entry a little bit simpler. Any other questions in there? Did anybody get started yet in the next chapter on systems of equations? That's what is coming next. Is that a yes, a no?
I have not yet.
Todd said no, Corin said no. Who already took test number, is this test number 2 or test number 3? Got my numbers mixed up. Test number 2. Who already took test number 2?
For chapter 3, I haven't.
For chapter 3. I'm gonna guess it's, I could go look, but I'm gonna guess it's mostly no's. Todd, did you take test number 3 yet? Or test number 2, chapter 3? I don't think anybody got to test 3 yet. That'd be way up ahead. Okay, I think what we'll do then, I'm gonna do a quick preview of what's coming in chapter 4, but we're not gonna do a ton of examples. In fact, I think what I'll do is I'm gonna do one problem, 1, 2, 3 ways. Okay, so we'll do one problem 3 different ways and then look at options in terms of solving. They're probably going to ask you in those sections to solve systems of equations a variety of ways. And I think once we see this, you're going to say, oh yeah, I remember doing these before, most likely. And if you don't, that's okay too, but I think most of you will probably remember seeing these. So I'm going to share from here. I'm going to escape there. And we're going to probably want to jump back out to, the to Desmos again in a little bit, but for right now, we'll just share from Zoom. So the way this works is that a system of equations, so system of equations, plural, sounds like there are at least two equations, and for us, there will be at least two. Theoretically, there could be just one, but then that's just an equation, so there's not really much to worry about. So we're going to start with systems of two equations in two variables. Now, in reality, these equations can be any kind of equations we want, but we're going to keep things a little bit simpler in that these are going to be linear equations. So two linear equations, two variables. Another way to think of this graphically is we've got two lines. So if I were to just quickly do a sketch, we're going to do three little sketches actually. Quickly do a sketch of three lines, or three pairs of lines. So here's one thing that can happen. The lines cross. And in a system of equations, the solution is the xy, the ordered pair, that satisfies both equations. And in terms of the lines, that means it's the point where they cross. Graphically, it's the intersection point. So the first graph is what normally happens. There's just one solution. So the two lines cross. We call this kind of system of equations a consistent system because it has a solution. And it's also called an independent system. That means it has just one solution. So that's where most of these lie. Most of the problems, just like when we solved equations, most of the equations we had one solution. Most of our systems of equations will have one solution, an x and a y value that go together as an ordered pair. But that's not all that can happen. So I drew two lines that crossed. How else could I draw two lines? Could I draw two lines that don't cross? I could make them parallel. In the case of parallel lines, do they have any points in common? Is there an XY on this line that matches an XY on that line? No, no points in common. So since they don't have any points in common, this system is called inconsistent. And there's no solution. So a little bit of terminology there. The last thing that can happen might not seem like a real problem, but it is. It could be that your two equations actually represent the same line. So you get one line and then the other line is just lying right on top of it. And when that happens, every point on the line satisfies both equations because it's the same line. So this is also consistent like the first one, but there are infinitely many solutions. So this is also called what we call dependent. So dependent means an infinite number, pound sign, so I don't run out of room, of solutions. So three things can happen. There's one solution, the lines cross. No solution, the lines are parallel. Or lots of solutions because the lines were actually the same. So we're going to do for our example that we do a few different ways. We're going to do the first case, the consistent independent case, where most of our problems will land. Okay, so I am gonna, let's add one here. And let's do something not too complicated. Let's go x plus y equals Corin's favorite number. Corin, give me your favorite number.
16.
16. All right, x plus y equals 16. All right, and then we're going to just make the second one slightly more complicated. I'm going to go 2x minus y equals 8. Okay, so we've got 3 ways to solve this. I mean, there are probably more ways to solve this, but right now we're going to talk about 3 ways. Sometime probably end of this week or maybe early next week, I'll also show you how to do these using some features on your graphing calculators. So that will give you a nice way to check things. All right, so 3 ways. Does anybody remember one way that they could come up with the x and the y that fit both equations? Other than kind of guess and check? We could guess
Can't
and
you
check.
add them together and then the y's cancel out?
That is a nice way. And even if the y's didn't cancel out right now, we could maybe multiply one of the equations by something to get that to happen. That was called the addition or elimination method. So that is one way we could do this. And the idea behind the addition method was, okay, let's add these guys together. Positive y plus negative y is 0, so those kind of go away. They cancel each other out. And 3 times x is 24. Once we do that, once we add the 2 equations together, we're down to an equation with just one variable, and we can work from there. So we can say, okay, well, I'm going to divide by 3 so that x equals 8. So add equations to eliminate variable. And you might need to multiply by something first. And then solve for the remaining variable. How do I get my y value? I've got x, so I've got half my solution. The solution is 8 something.
Plug x in.
Yeah, and it doesn't matter which equation you use. So we're going to just say substitute or plug in in order to solve for the other variable, whichever one is we don't have yet. And again, make things easy for yourself. I'm going to take the top equation, 8 plus y equals 16, subtract 8, y also equals 8. And there's my solution, the 0.88. And I can check 8 plus 8 is 16, so that one's good. 2 times 8 is 16, minus 8 is 8, so the second one is good. That point fits both equations and is my solution. So that's the addition or the elimination method. Can anybody remember a different algebraic method for solving these guys? So this will be number 2. I think we can get number 2 on this same page. So we're going to do the same problem. Hopefully get the same solution. It's actually just called the substitution method. I like the first one better, quite honestly, because it avoids fractions in pretty much in most of the cases. But the substitution method isn't bad as long as you don't have some messy numbers in here. You're going to solve for one of the variables in either equation. Doesn't matter. I usually pick the simpler equation. So in this problem, I would probably start by saying, okay, well, y equals 16 minus x. And then once you have that, you're going to substitute, and here's the key, what you just got into the other equation. So you have to use the second equation now, not an S, equation. So 2x minus y, 16 minus x, equals 8. The biggest thing here is to make sure you're very careful with maybe distributing and negative signs. 2x minus 16 plus x equals 8. And you can convince yourself that that says 3x equals 24. So x equals 8 again. And y is 16 minus 8. Y equals 8. And we got the same exact solution, 8, 8. So sometimes students like to use one or the other of those two methods all the time. I would not recommend using the second method if it's leading you to lots of fractions, because that sort of lends itself to lots of ways to mess up. But you can if you really want to. All right, one more method, and we're going to just add a page. So x plus y equals 16 and 2x minus y equals 8. X plus y equals 16 and 2x minus y equals 8. This one is usually students' least favorite. It's the graphing method. It is the best, though, in terms of showing you what the solution is. And remember, we can always check our work on our graphing calculator or in Desmos. So with the graphing method, I'm just going to take one grid and I'm going to graph both lines, and then I'm going to find the intersection point. So let's see, x plus y equals 16. I'm going to use my intercept method. When x is 0, y is 16. So I'm going to go 5, 10, 15, 20. So 16 would be about right there, 0, 16. And when y is 0, x is 16. 5, 10, 15, 20. So 16, 0 is about there. And we'll play connect the dots with hopefully a fairly straight line. This is way easier to do on a flat piece of paper than on a board or a screen, but that's not too bad. So I've got my first line. I have to draw my second line. So 2x minus y equals 8. When x is 0, let's see, negative y equals 8. So y equals negative 8. 0, negative 8, 5, 10. About right there. By the way, if you're doing these at home, it's a way easier to do on graph paper too, because you'll make sure that your spacing is equal. If y is 0, I get 2 times x is 8. So x is 4. So 4, 0. About right there. And again, play connect the dots. And the point in question, the one that we need, is the point where they cross. So this is hard to do without a grid, but we could kind of estimate. It looks like about 8, it looks like about 8, it looks like it's the 0.88. And if you're doing these by hand on paper without a calculator, you should always check. So we should check and make sure that that fits, but we already checked that point and we know that's the solution. So if they tell you to use the graphical method, you need to draw the 2 lines and find the intersection point. Now keep in mind that you've got all sorts of technology to help you out. So you can go back and use your graphing calculator and graph the 2 lines and find the intersection, but you can also use Desmos even more easily. So if we're gonna switch out the screen share and continue. Looks like I don't have Desmos open anymore, so I'm just going to switch over here. There it is. And I'm going to get rid of what we did before. And I'm going to graph my 2 lines. You guys can help me remember x plus y equals 16. And 2x minus y equals 8. And there they are. And I'm interested in the intersection point, and I know I'm correct because there it is, 8, 8. Oops, I have a plus plus y, but that wasn't any harm, so I'm okay there. Okay, so does that make sense? So when you solve a system of equations, you're looking for the point or points that satisfy both equations. And you got 3 methods for these 2x2 systems. You can solve by graphing. You can solve by the substitution method, and you can solve by the addition or elimination method. Does that give you somewhere to go moving forward? I think I want to let you guys work on those. So we have about 50 minutes left. We're actually going to finish a little bit early today. I'm going to cut out of here by about 1:45, even if there are still people here, so I can answer questions later if anybody needs it. But I'll stick around until 1:45 as long as people stay. So if you guys want to just work on homework and hang out in the Zoom room and then ask questions if you run into them, you can do that. Or if you have questions right now you want to ask, go ahead and shoot, and we'll put them up. But otherwise, I'm going to just let you guys work on some homework and ask questions as you run into them. When I did Samantha, I'm not sure what you mean by that. What do you mean? What did I put it equal to?
But like the approximate thing.
Oh, okay. So yeah, that was like this. The approximate thing, you have to type Y1. I'm going to type in chat. I'll say it for now, and then when I hit enter, you'll be able to see it. And then the little tilde, and then mx1 plus b. So it's kind of like that.
Okay.
Those ones are little subscripts, and Desmos makes those subscripts automatically.
Okay.
If you're using the calculator, then you're just going to just dump that regression equation into your y1, into your y equals. So it's a little bit different. Are you working on one right now, Samantha?
Yeah.
Okay.
And it wants me to try to find 13, so I don't know how to find 13.
Oh, you mean how to find the y value when x is 13?
Yeah.
Are you doing Desmos?
Yeah.
Okay, let me share and I'll show you. So I'm not even gonna, actually, yeah, I will. So let's, I think the last thing I did, yeah, there's some points. So there's those ones that they had given me from before, and then there's gonna be my equation. Okay, so now I've got my equation. So it's y equals 0.32x plus 4.11. What I would do is, if I needed to figure out what happens when when x equals 13, is that what they want? I would just do this. M, because M has a value. See how that shows up?
Uh-huh.
Times 13 plus B. If you really don't trust it, you can type the numbers, but this truly does work.
Okay.
Now, if they had given you the y value instead, like maybe they say find the x value when y equals 13, then you're gonna actually just have to write it down and do a little bit of work, right?
Right.
So you would write down 13 equals 0.32x plus 4.11, and then solve for x. And in that case, you should leave the m and b values in your calculator, so that even though you're only writing down 2 places after the decimal, you're still using all of those decimal places in your calculation.
And it says to round to the nearest hundredth, and I did it. It said my answer's wrong.
Okay, so let me go see what happened. Okay, I'm gonna stop share and then go back over here. That was you, right, Samantha?
Yeah.
Okay. Is this the first problem you tried?
Yeah.
Okay. So it's not going to let me see it until you completely finish the problem. So tell me what you got.
For the value?
Yeah, tell me what you got for your M and your B.
For M, it's 1.6131.
Okay, tell me the next digit.
What do you mean?
1.61 what?
317.
Okay, so 1.61. I'm just checking your rounding. And then for B, what was it?
4.17656.
So 4.18.
So then it gave me 25.147. So I did 25.15.
Okay. All right, so let's see. I can, can you share your screen with me again, Samantha?
Yeah.
I'll pin you back up there.
I don't know if you want to see this or if you want to see the calculator.
No, this is good. I want to see this. I'm gonna put these on my calculator real quick,
Okay.
mainly because I can look at my calculator and look at the screen. It's gonna be hard to jump back and forth to Desmos though, so I'm gonna do this here. Okay, so I'm going 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that it? Was 10 the last one? 9.58. You hid that. Was 10 the last one?
Yep.
Okay. So scroll that. Yeah, there we go. 7.46, 9.28, 11.58, 14.94, 14.97, 18.43, 18.04, and then I need to see the last one, 20.42. Okay. Okay, so did you get 1.6131 and then a bunch of sixes?
Yeah.
And then
That's the best one.
4.1176 and then a bunch of fives?
Yep.
Okay, so that looks good so far. And then they wanted us to calculate for x equals 13. And you're doing this in Desmos, right?
Yeah.
Okay, so it shouldn't really. Little a. Little a. Okay, I got 25.15.
That's what I put for my answer. And they say it's wrong.
Really? You put 25.15?
Yep. And it says find the value of y at x equals 13.
Okay, so let me try this before you enter another answer. Okay, try 25.11. And wait, no, stop. Yes, 25.11. And see if it gives it to you right.
Yes.
Okay, so here's what it did. At least this is how I got that answer. They rounded the numbers, the M and the B, before they did the calculation. Which is
Because they
not really best practices, but that's what they did. So try it with the rounded number. So what I did is I entered 1.61 times 13 plus 4.18. So I used the rounded numbers to do the
And that's what
calculation. So
that's
try
what they're
that on the future ones.
Okay.
Okay. Corin, are you just working on problems?
Yeah.
Okay, I am going to actually